So let's understand the heap memory now. So heap is a non-contiguous block of memory and can be increased as per the requirement of the application. And we can also delete any object from the heap memory in any order. As stack is follow LIFO principle, so the first object should be deleted from the top of the stack. But in case of heap memory, we can delete any item from the heap memory. So there is no need to follow any particular order when we storing the data on the heap memory. So heap do not follow any particular order when storing the data on the heap memory. So let's discuss heap memory with the help of this diagram. So in our application, suppose there are 4 variables. First one is args, that is of type array of string. The next 3 objects are of type employee. Suppose our application, we have declared one employee class and we are creating the object of that class E1, E2 and E3. And E3 is also pointing to the E2 only. So same copy would be shared with employee E2 object and employee E3 object. So all the value type variables would be stored on the stack memory and all the reference type variables would be stored on the heap memory. So these are the reference variables which are storing the exact memory address where the object was created on the heap. So here employee object contains 4 attributes: name, SSN, email address and year of birth. So name, SSN and email address are of type string variables. So those are the reference type variables. So those are pointing to the memory location where the exactly data is stored on the heap memory. But in case of year of birth, it is an integer type and it is a value type. So that's why it is stored here only instead of pointing to some other memory location. The heap is a region of memory used for dynamic memory allocation. It stores reference types and large objects that are allocated and managed at runtime. Unlike the stack, the heap does not have the LIFO constraint, meaning objects can be created and destroyed in any order. It's non-contiguous memory. So as we discussed, it will not follow any principle and we can delete any objects from the heap memory in any order as per the requirement of the application. So these are the key characteristics of the heap memory. It will store only the reference type variables. Objects of reference types like class, arrays, delegate, and string are stored on the heap. The variable in the stack contains a reference, nothing but the pointer to the memory location in the heap. So in previous diagram, we have discussed the reference variables would be stored on the stack memory. So these are the pointer variables which are pointing to the memory location where the exact object is stored on the heap memory. So it will store the memory address of the object which was stored on heap memory. Dynamically allocated. Memory for objects is allocated on the heap when you create an instance using new operator. For example, suppose we have my class and we are creating the object of that class by using keyword new over here. So that will allocate the memory on heap instead of stack. Garbage collection. Memory in the heap is managed through garbage collection. As we are aware, stack is maintained by the runtime environment, and as soon as any function returns a call to its calling function, the memory would be deleted from the stack memory. So in case of heap memory, that can be managed by the garbage collector. So memory in the heap is managed through garbage collection process. The .NET runtime tracks objects that are no longer in use and automatically frees their memory. So as compared to the stack memory, heap memory is slower because accessing heap memory is slower than stack memory due to the need to dereference pointers. That is finding the actual data through references which was stored on the stack memory. So it is non-contiguous memory and we are storing the memory address in stack. So need to find out exact objects if you want to use that object. So that's why it is slower as compared to the stack memory. It is in larger size. Heap memory is much larger than the stack memory and can store large objects or many smaller objects. So in this program, we have one class person, which contains two attributes. One is string type and another one is integer type. So the name is a string type and age is a integer type. So in create person function, we are creating the object of person class by using new operator. So it is a reference type variable. So that's why it would be stored on the heap memory. And now we are assigning some values to the name and age attributes. So name is a string type variable. So it would be stored on the heap memory, and age is the integer type. Even it is a value type, but it is a part of the person class. So that's why it would be stored on the heap memory. So let's understand the difference between stack memory and the heap memory. So the first aspect is type of memory. So stack memory is the static type and the heap memory the dynamic type. So the stack memory is in fixed size. So the memory is allocated to that application. It is a fixed size for stack memory. And in case of heap memory, it can be increased gradually as per the requirement of the application. So the second aspect is data stored. So what type of data would be stored on the stack? All the value type variables which are declared as a local variables, not the global variables, and method calls would be maintained in stack memory. And all the reference type variables and large objects would be stored on the heap memory. So the next aspect is memory management. So as soon as any function completes its functionality, the memory would be delocated by the CLR from the stack memory. And also it follow LIFO principle. Heap memory is managed by the garbage collector instead of CLR runtime environment. So the next aspect is access speed. As stack is a contiguous block of memory, so it is faster than the heap memory. But heap memory is slower due to the reference lookup, as we have discussed in previous slide. So the next aspect is memory size. It is smaller and limited as compared to the heap memory, and heap memory is larger and more flexible because it will not follow any principle while we are deleting any objects from the heap memory. We can delete any objects from the heap memory, but in case of stack, we need to follow LIFO principle. So the next aspect is lifetime. Bound to method scope, automatic cleanup. So as soon as function completes its functionality, all the local variables which was declared in that particular function, the memory would be deleted by the runtime environment immediately. But in case of heap memory, it would be deleted by garbage collector. So the next aspect is common usage. So all the local variables and value type variables are stored on the stack. And objects and arrays and classes. So these are the reference type variables. So that would be stored on the heap memory. So in this example, there is an integer variable which contain value 10. Also, we are declaring integer B and we are assigning variable A. So it will create a separate copy on stack because these are the value type variables. So first memory would be allocated for A variable and we are assigning this value to B. So it would be stored on stack as well. But in case of heap, suppose there is a string variable, it is a reference type variable. So the actual hello string would be stored on the heap instead of stack. And both variables, that is nothing but the reference variables, are stored on the stack, but pointing to the same memory location, that is nothing but the 5000. 5000 is the actual memory address where the hello string is stored on the heap. So here we are assigning SS is equal to S. It means that the string, only the one copy of string is stored on the heap, but both are pointing to the same memory location. So even if we change the value of S or SS, both variables would get updated because both are pointing to the same memory address.